Hello. Okay, so I apologize if you cannot read the title here, but the title that says Laws of Exponents. So that's the title, right? So you may have learned this in Algebra 1, or you may have not, but we'll see. We'll go over it anyway. All right, so we're going to go over different exponent rules. We're going to derive each of these exponent rules here, okay? So what we have here is, here's an example. So if we have a cubed times a to the fifth, so that's the same thing as a times 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 a. So if you multiply all these things together, you get a raised to the 8th power. So in other words, what's happening here is you have a 3 and a 5 here, so you would add those exponents. So 3 plus 5 is going to be 8. So the exponent rule that would go here is a raised to the m power times a raised to the n power, and that's the same thing as a raised to the m plus n. So in other words, you would add the exponents. Okay, division, if you look at division here, we have 6 a's. We have 6 a's here, and then we have 2 a's. What you realize if you write this out, 2 a's are going to cancel out, and then you're left with a raised to the 4th power. So in other words, you have the exponents here, so 6 minus 2 is going to be 4. If you see a pattern, this would be a raised to the m power divided by a raised to the n power, and then we're left with a raised to the m minus n for division. Okay? The power one, if you look at the power law here, if you have a squared raised to the 4th power. So this is just a times 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 a. So if you look at this, our result is a raised to the 8th power. So in other words, if you're left with something like this, you would multiply the exponents together. So the notation for this would be a raised to the m power and raised to the n. Essentially what you would do is you would multiply the exponents. So you'd multiply the exponents. So it looks like that. Okay. This one, power of a product. So power of a product, this one basically says, so you have a squared times b cubed. So you write that 3 times. And if you notice here, a squared times a squared times a squared is going to be a to the 6th, and then b times b times b is b cubed. So what you have here as a result is this exponent is just going to go inside here. So the rule, because 2 times 3 is 6, and then if this is if you imagine there's a 1, 1 times 3 is going to be 3. So basically, what this will come out to be, this is going to be a times b raised to the m power, and this is the same thing as a to the m. Oh, let me write that again. A raised to the m times b raised to the m. Okay? Power of a quotient. Power of a quotient rule. So basically, you write this thing 5 times, and as you notice here, a times a times a times a times a is a to the 5th. 3 times 3 times 3 times 3 times 3. Sorry, wait. Yeah. A times a times a times a times a is a to the 5th. And then b cubed times b cubed times b cubed times b cubed times b cubed is going to be b to the 15th. So in other words, you just add the exponents 3 plus 3 plus 3 plus 3 plus 3. And what you have here is you have a 1 here. So 1 times 5 is going to be 5. And then 3 times 5 is going to be 15. So in other words, the rule that would go here is going to be a over b and then raised to the m power is the same thing as a to the m divided by b raised to the m. Okay? Now, The next thing I want to discuss is the zero exponent rule. So you may have learned in Algebra 1 that anything raised to the zero power is 1. And you might be wondering, well, why? Okay, so let's take that division rule. If you take that division rule, so you have a raised to the m divided by a raised to the n, and we said the division rule says that you subtract the exponents that you see. Let's take an example where m equals 3 and n equals 3. Okay? So if we were to do that, if we were to substitute m and n, so we have a cubed, m is 3, and then n is going to be 3. So this is a cubed. Anything divided by itself is going to be 1. But we also know that a cubed minus a divided by a cubed, if we follow this rule, is going to be a cubed minus 3. So 3 minus 3 here is a to the 0. So in other words, if you look at these expressions, these right here are the same. So what this means is anything to the 0 power is going to be 1. And this literally holds true for anything. So for example, if I were to do x times y raised to the 0, that would be 1. If I did 23 raised to the 0, this would be 1. If I had something complicated, 3 pi z times h raised to the 0, that's going to be 1. These are all examples where you raise something to the 0 power, and it's going to be 1. Okay. I'm going to show you one more example. And oh yeah, so if you're wondering, so this, sorry, I should have mentioned that earlier. This is called the zero exponent rule. This is called the zero exponent rule. Okay, so I'm going to just show you another example. So this is one is the negative exponent rule. So we're going to take that same example. So a to the m divided by a raised to the n. And let's say m is 0 this time and n is 3. Okay, so if we do this, we have a to the 0 divided by a cubed, and then this is the same thing as a to the 0 minus 3, which is a raised to negative 3. Okay, now another way that we can also think about this, right? So we have a raised to the 0. What I just mentioned earlier is that anything raised to the, I deleted it. Anything raised to the 0 power is going to be 1. Okay? So what this means is that these expressions here are the same. These expressions here are the same. So in other words, a raised to the negative 3 equals 1 over a cubed. So in general, the negative exponent rule, so the negative exponent rule basically says that if you have a raised to the negative n, it's going to be 1 over a raised to the n. So that would be another example. So I'll give you some examples. I'm running out of room. I'm just going to show you some examples of what that would look like. So for example, if you have a raised to the negative 2, that's the same thing as 1 over a squared. If you have x raised to the negative 4, that's the same thing as 1 over x raised to the 4th power. Lastly, if you have x raised to the negative 9, that's the same thing as 1 over x to the 9th power. So yeah, just so you guys could see some examples of how the negative exponent rule is applied. Okay, so I'm going to keep this video to 10 minutes. I'm going to show you one more example with exponents and rules. I will see you guys in the next video. Okay, bye.